Hi, I'm Gopika Sudhakaran and welcome to our ICCV 23 poster on Vision Relation Transformer for Unbiased Scene Graph Generation, a joint work with Devendra Singh Dami, Kristen Kirsting, and Stefan Roth from TU Darmstadt. Scene graphs are graphical representations that capture various objects within an image along with the relational dependencies between them. Let's review the conventional pipeline for scene graph generation. An image goes through an RGB feature extractor to generate visual cues and a proposal network to generate semantic and location cues. The cues for each entity bounding box region is globally projected, resulting in global patches for all the entities, where each patch corresponds to entire bounding box region of a single entity. These global patches are processed by the encoder network, which are then split into subject and object relation components. For instance, to establish the woman riding horse relationship, the subject part of the woman's patch in green merges with the object part of the horse's patch in red. This combined entity patch then goes through the relation decoder network, resulting in riding relation. Similarly, we get the wearing relation for woman and hat entities. A drawback of conventional SCG is its parameter-heavy global entity projection, which in turn result in local level information loss in the image. Establishing the attached to relation between the handle and the basket lies more on the corner tile details of the handle than the center tiles. Global projection may risk losing these crucial features. Another challenge is that the debias models are still biased. Let's examine various popular debiasing techniques applied to the motifs SDG network in which the y-axis displays a trade-off. On the positive side, there is a relative improvement in mean recall at 100, while on the negative side, there is a relative drop in recall at 100. These models significantly sacrifice recall for the state-of-the-art mean recall improvement. Hence, to overcome the challenges, we propose V2, a vision relation transformer. It uses the same backbone and proposal network as our baselines, but generates depth-related geometric cues using a depth network and depth feature extractor. Most importantly, V2 employs entity local level path generator instead of global projection, which includes cross-relation and cross-modality modules. At first, visual cues of the subject and object entities goes through the cross-relation modules where they are pooled, fused, and passed to the cross-modality patch fusion module where each modality is split into multiple blocks channel-wise. The resulting blocks are projected and fused to form input tokens, each containing a smaller portion of the entity, in contrast to the conventional SGGs where each token represents the entire entity. The location and semantic cues of the subject and object entities are fused as additional input tokens. Thus, tokens corresponding to entity pairs, woman and horse, are processed to predict the riding relation. Similarly, we get the relation prediction wearing for woman and hat entities. To further debias V2, we propose MEET, Mutually Exclusive Expert Learning Setup. It starts with splitting the dataset sorted based on its predicate frequency distribution into multiple groups. Let's consider three experts with sample A from group 1 and sample B from group 2. Expert 1 is trained on in-distribution samples from group 1 and out-of-distribution samples from groups 2 and 3. Expert 1 predicts a relation for A while B is out of its classification space. Similarly, expert 2 is trained on in-distribution samples from group 2 and out-of-distribution samples from groups 1 and 3. Expert 2 predicts relation for B while A is out of its classification space. Expert 3 encounters both A and B from groups 1 and 2 as out of its classification space. Out-of-distribution predictions made by the experts are discarded. Predicate classification performance of V2 in comparison to the baselines reveal that V2 attains much better recall versus mean recall trade-off as evident in their average shown in the A at K column. Furthermore, applying mean debiasing to the baselines and V2 shows that V2 with mean outperforms the baseline models on both recall and mean recall. Interestingly, comparing the performance of mean debiased SCG models based on their number of trainable parameters reveal that V2 outperforms the baseline models while being 10 times lighter. For additional details, results and discussions, please find our paper and code online.